The Soviet Union built a 640-ton aircraft that could carry entire locomotives, a tank with 5 turrets requiring 12 crew members, and a missile-launching boat that flew just above water at 340 miles per hour. While the West focused on practical engineering, Soviet designers created machines so outrageous, they seemed pulled from science fiction. These weren't concept drawings or propaganda fantasies, they were real, operational vehicles that pushed the boundaries of physics and common sense. Welcome to the most insane chapter of military engineering history. The Antonov and 225 Mriya, the Sky Titan. A single aircraft engine failure would ground most planes, but the An-225 Mriya could lose 3 of its 6 engines and still fly safely. This Ukrainian-built monster wasn't just the world's largest aircraft, it was a flying impossibility that redefined what could take to the skies. Stretching 275 feet long with a wingspan wider than a football field, the Mriya weighed 640 tons when fully loaded. Its cargo hold could fit 50 cars or house 4 crew members comfortably in its engineering bay. The aircraft required 32 wheels just to distribute its massive weight on runways, with 20 of those wheels being steerable for ground maneuvering. Originally designed to piggyback the Soviet Buran space shuttle, the Mriya became a commercial cargo hauler after the space program ended. It routinely transported objects once thought impossible to move by air: 130-ton generators, wind turbine blades longer than most aircraft, and even diesel locomotives. The sight of this 6-engine giant attracted crowds wherever it landed, becoming a symbol of Ukrainian engineering pride. The aircraft's unique design featured twin vertical stabilizers and engines mounted above the wings to avoid ground debris when loading oversized cargo. Its maximum altitude of 36,000 feet meant it could fly intercontinental routes while carrying payloads that would require multiple cargo ships to transport by sea. Tragically, the only completed Mriya was destroyed during the 2022 Russian invasion of Ukraine, ending the operational life of aviation's most ambitious achievement. The T-35 heavy tank, the land battleship. Imagine a tank so massive it needed 11 crew members and got lost because its own turrets blocked the driver's vision. The T-35 wasn't just a tank, it was a mobile fortress that embodied Soviet excess in armored warfare. At 45 tons and nearly 32 feet long, the T-35 featured 5 turrets bristling with weapons: one 76mm main gun, 2 45mm cannons, and up to 7 machine guns. This firepower required a crew larger than most aircraft, with gunners, loaders, and commanders spread across separate fighting compartments that couldn't communicate effectively with each other. The tank's design philosophy assumed it would break through enemy lines while creating a sea of fire around itself. In reality, the T-35 proved mechanically unreliable and strategically useless. Its 500 horsepower engine could barely push the massive hull to 19 miles per hour on roads, and cross-country mobility was practically non-existent. Only 61 T-35s were ever built, making them more valuable as parade vehicles than combat weapons. During World War II, most T-35s were lost to mechanical breakdowns rather than enemy action. The few that saw combat were quickly destroyed or abandoned when their complex systems failed under battlefield conditions. The T-35 represented the interwar period's obsession with multi-turreted land battleships, a concept that looked impressive on paper but proved disastrously impractical in real warfare. It remains the only 5-turreted tank ever to reach mass production, a testament to Soviet willingness to build the impossible. The Lun-Class Ekranoplan, the flying warship. Soviet engineers created a 240-foot missile-armed vehicle that wasn't quite a plane and wasn't quite a ship. It was something entirely new that skimmed across water at 340 miles per hour while carrying enough firepower to sink an entire naval fleet. The Lun-Class Ekranoplan exploited ground effect physics, using the air cushion created between its massive wings and the water surface to achieve lift without actually flying. This allowed the 240-ton vehicle to cruise just 13 feet above the waves, too low for radar detection but too fast for naval defenses. Armed with 6 P-270 Mosket anti-ship missiles, the Lun could engage targets 75 miles away while remaining virtually invisible to enemy sensors. Its 8 turbojet engines provided enough thrust to accelerate this flying fortress to speeds that would make most naval vessels look stationary. The craft's unique design challenges included saltwater corrosion from constant spray, limited operational conditions requiring calm seas, and the need for specially trained pilots who understood both aviation and maritime operations. The International Maritime Organization classified Ekranoplans as ships rather than aircraft, creating regulatory confusion that persists today. Only one Lun-Class Ekranoplan was completed before the Soviet Union's collapse ended the program. The surviving vehicle now sits as a museum piece on the Caspian seashore, a reminder of Soviet ambitions to revolutionize naval warfare through physics-defying engineering. The Buran space shuttle, the Soviet space phantom. While NASA's space shuttle required pilots for every mission, the Soviet Buran accomplished something American engineers thought impossible. It flew to orbit and landed completely unmanned, controlled entirely by computers in an era when most people had never seen a personal computer. The Buran program represented the Soviet Union's most expensive space project, involving over 1,000 companies across the country. Unlike the American shuttle, which carried its main engines into orbit, Buran rode atop the massive Mriya rocket, making it a true passenger spacecraft rather than a rocket-powered aircraft. On November 15, 1988, Buran completed its only spaceflight, a flawless two-orbit mission lasting 208 minutes. The spacecraft launched automatically, maneuvered in orbit using onboard computers, and executed a perfect runway landing without any human intervention. This automated capability was decades ahead of its time, predating modern autonomous vehicle technology by 30 years. The shuttle's cargo bay could accommodate satellites up to 56 feet long, and its crew cabin was designed for 6 cosmonauts. Additional crew members could ride in the cargo area for specialized missions. The spacecraft's heat shield used different materials than NASA's shuttle, optimized for the harsh conditions of Soviet launch sites. Despite its technological success, Buran never flew again. The Soviet Union's collapse in 1991 ended funding for the program, and the only operational orbiter was destroyed in 2002 when its storage hangar collapsed. The program's cancellation marked the end of Soviet dreams of routine space transportation. The VDNKh robot, the Soviet android dream. In 1959, when most people thought robots existed only in science fiction, Soviet engineers unveiled a 1.8-meter humanoid robot that could execute 18 commands, respond to light and sound, and perform for amazed crowds at Moscow's VDNKh exhibition center. The VDNKh robot represented the Soviet Union's early experiment in humanoid robotics, designed to showcase technological superiority during the Cold War. Standing on a specially built stage in front of the electrification pavilion, the robot performed demonstrations every 2 hours, combining engineering achievement with theatrical showmanship. This early android could perform basic human movements, respond to voice commands, and navigate simple obstacles using primitive sensors. While crude by modern standards, the robot's capabilities were revolutionary for the 1950s, predating industrial robotics by decades, and demonstrating Soviet commitment to automation technology. The robot's design philosophy reflected Soviet optimism about human-machine collaboration, envisioning a future where robots would support workers in factories and daily life. Its public demonstrations captured imaginations and inspired a generation of Soviet engineers to pursue robotics research. The VDNKh robot's legacy extends beyond its mechanical capabilities to its cultural impact, representing a time when robotics was emerging as a field full of promise. It embodied the Soviet Union's drive to innovate through technology, blending practical demonstration with symbolic hope for technological progress that would define the space age. The MAZ-7907, the 24-wheeled nuclear nightmare. Soviet engineers built a truck so massive it needed 24 wheels, 2 tank engines, and electric motors at every wheel, just to move a 100-ton nuclear missile across rough terrain. And only 2 of these mechanical monsters were ever completed. The MAZ-7907 stretched 92 feet long and weighed 66 tons empty, designed specifically to transport the RT-23 Molodets intercontinental ballistic missile. This road-mobile nuclear launcher represented the ultimate expression of Cold War mobility, capable of carrying world-ending firepower to any location accessible by road. 2 1,250 horsepower gas turbine engines from T-80 tanks powered electric generators that fed individual motors at each of the 24 wheels. This turbine electric drive system allowed the massive vehicle to navigate rough terrain while maintaining the precision needed for missile deployment. 8 of the 12 axles were steerable, enabling surprisingly tight turns for such a massive vehicle. The truck's articulated frame and independent hydropneumatic suspension for each wheel helped it traverse difficult terrain without losing stability. Despite weighing over 200 tons when loaded, the MAZ 7907 could achieve speeds of 25 miles per hour on roads and maintain mobility across unpaved surfaces that would stop conventional vehicles. The end of the Cold War eliminated the need for road-mobile nuclear missiles, leaving the MAZ 7907 without a mission. One surviving chassis was later used to transport an 88-ton ship 250 kilometers across Belarus, proving the vehicle's incredible load-carrying capability, even in civilian applications. The Caspian Sea Monster, the original Ekranoplan. American spy satellites detected something so bizarre skimming across the Caspian Sea that CIA analysts couldn't determine if it was a plane, a ship, or something entirely new. They simply called it the Caspian Sea Monster, and it became one of the Cold War's most mysterious weapons. The KM, or Korabel Maket, was the world's first operational ground effect vehicle, a 348-foot experimental craft that flew just above the water surface using 8 massive turbojet engines. Weighing over 540 tons, it was simultaneously the heaviest aircraft and fastest ship ever built when it began testing back in 1966. This flying Leviathan exploited ground effect physics to achieve impossible performance, skimming across water at speeds up to 460 miles per hour while remaining invisible to radar. Its massive size, longer than a Boeing 747 with engines producing 127,000 pounds of thrust, made it detectable by satellites but honestly incomprehensible to intelligence analysts. The KM's experimental nature meant constant testing and modification throughout its operational life. Soviet engineers used it to develop techniques for ground effect flight, leading to later military applications like the Lun-Class Ekranoplan. Its unique capabilities included the ability to carry massive payloads at aircraft speeds while operating from any large body of water. The monster's career ended in 1980, when pilot error caused it to crash into the Caspian Sea during a test flight. No lives were lost, but the unique vehicle sank and remains on the sea floor, taking with it secrets of Soviet ground effect technology that took decades to fully understand. The Zveno flying aircraft carrier, the aerial mothership. Soviet engineers solved the problem of limited fighter aircraft range by creating something that sounds like science fiction. A massive bomber that carried smaller fighter planes on its wings and released them in mid-air for combat missions. The Zveno project transformed a TB-3 heavy bomber into a flying aircraft carrier, mounting up to 5 smaller aircraft on its wings and fuselage. I-16 fighters would attach to the bomber before takeoff, ride to the target area, then detach for independent combat operations before returning to land at conventional airfields. This aerial mothership concept addressed the fundamental limitation of 1930s fighter aircraft. Their short range made them useless for long-distance missions. By carrying fighters to the battle zone, the Zveno system extended their operational radius by hundreds of miles, effectively creating mobile air bases that could appear anywhere within the bomber's range. The system required extraordinary pilot skill and precise coordination. Fighter pilots had to attach their aircraft to the bomber's wing mounts, ride through potentially turbulent flight conditions, then detach cleanly without colliding with the carrier aircraft or other fighters. The complexity of these operations limited the system's practical applications. Despite successful testing and limited combat use during World War II, the Zveno concept was abandoned as aircraft technology advanced. Longer-range fighters and aerial refueling made the flying aircraft carrier unnecessary, but the project demonstrated Soviet willingness to pursue unconventional solutions to tactical problems. The 1K-17 Szhatie laser tank, the Soviet death ray. While science fiction promised laser weapons in the distant future, Soviet engineers built a working laser tank in the 1970s that could blind pilots and destroy optical equipment using focused light beams generated by synthetic rubies weighing 66 pounds each. The 1K-17 Szhatie mounted an array of 13 laser emitters on a tank chassis, each focusing powerful light through synthetically grown rubies to create coherent beams capable of damaging enemy equipment. Unlike modern military lasers designed to burn through targets, the Szhatie was built to blind and disorient rather than destroy. The system's ruby-based laser technology represented cutting-edge Soviet research into directed energy weapons. Each ruby crystal required precise manufacturing and alignment to focus the laser beams effectively, making the entire system incredibly complex and expensive to maintain. Combat applications included disabling enemy optical systems, blinding pilots during low-level attacks, and potentially damaging sensitive electronic equipment. The laser array could fire in pulses to prevent overheating while maintaining effectiveness against multiple targets. The Szhatie never saw combat deployment, remaining an experimental system throughout its development. The complexity of maintaining the laser array, combined with the emergence of more practical anti-aircraft systems, led to the program's cancellation. However, the technology developed for the Szhatie influenced later Soviet research into directed energy weapons. The Bartini Beriev VVA-14, the Soviet Millennium Falcon. 5 years before Star Wars introduced the Millennium Falcon, Soviet designers created an aircraft that looked like it came from a galaxy far, far away. A vertical takeoff amphibious plane designed to hunt American submarines anywhere in the world's oceans. The VVA-14's bizarre elliptical shape served multiple purposes. The entire fuselage acted as a lifting body, while inflatable pontoons allowed water operations and vertical takeoff capability. This unique design enabled the aircraft to operate from land, water, or even rough seas where conventional seaplanes would be destroyed. Designed by Italian engineer Roberto Bartini, working in the Soviet Union, the VVA-14 was intended to counter American Polaris submarine-launched ballistic missiles. The aircraft would patrol vast ocean areas, using its amphibious capabilities to land on water for extended surveillance missions or emergency operations. The prototype's test flights revealed both the promise and problems of its unconventional design. While the lifting body concept worked, the complex systems required for vertical takeoff and amphibious operations proved unreliable. The aircraft's unique appearance and advanced capabilities made it a showcase of Soviet aerospace ambition. Only one prototype was completed before the program ended in the mid-1970s. The VVA-14's influence on science fiction design is unmistakable, and its advanced concepts predated modern vertical takeoff aircraft by decades. The surviving prototype remains a testament to Soviet willingness to pursue revolutionary aircraft designs. These 10 mechanical monsters prove that Soviet engineers never met an impossible idea they wouldn't try to build. From flying tanks to nuclear-powered trucks, they created machines that pushed physics to its limits and common sense beyond recognition. While many failed spectacularly, others achieved the impossible and changed military technology forever. What's your favorite Soviet engineering nightmare? Share your thoughts below. Hit that like button if these crazy machines amazed you, and subscribe to Future Facts for more incredible stories of human ingenuity gone wild. Until next time, keep questioning everything.